Energy recovery is an essential part of the ventilation system. And as such, let's look into how we can inspect and evaluate the on-site equipment to ensure the ventilation system's efficiency. The following serves as an inspection for the ERV unit in general. Some of these items may seem trivial, but you'll really be surprised how often they get overlooked. If you believe the ERV system has been exposed to infectious aerosols, please treat all materials and surfaces as they have been exposed. This includes following all the guidelines posted by the medical community, which includes but not limited to wearing the appropriate personal protective equipment. Typically includes wearing N95 masks, non-permeable gloves, and providing adequate ventilation to the inspecting area. When addressing the efficacy of the ERV unit, quite a bit of that process is based on items that would affect overall flow and pressure. So in general, you're going to want to ensure that the airflow paths are not obstructed and really are free and clear of any debris or blockage, as well as trying to determine if there's any gross leakage between air streams. So specifically, these are the items you should look for. Are the intake and exhaust louvers and screens clean and clear of any debris? Are the filters clean? Keep in mind that some units will have multiple filters in multiple areas of the cabinet, and this includes both the supply and exhaust air streams. Are there any internal gaps? What you'd want to check for is inadvertent gross leakage. You're going to want to check the areas around the air partitions inside the cabinet that could attribute to any potential flow leakage. This could be from seal deterioration, missing fasteners, loose panels, or panels that may have been removed over time. You'd be pretty surprised how routine maintenance and service can inadvertently attribute to some of these items. Another way to determine for any possible leaks is to shine a light in different sections of the air handler and to see if there's any penetration between the different cabinet sections. Are the dampers in good working order? You're going to want to check to make sure that they aren't jammed and the seals are seating properly. If the unit is equipped with coils, are they clean? If during the inspection you found or discovered any of these items that may need to be cleaned, you would consult with the manufacturer to determine the proper cleaning method. Also, if you found any malfunctioning items, you would also fix those accordingly, and also patch any paths for leakage before starting the unit back up. The next set of steps are for an inspection and evaluation of an energy recovery component. And then after this section, I'm going to discuss some of the remediation methods for the items discussed in this section. So during the general inspection of the unit, it should have given you a general layout of the cabinet and the areas that surround the energy recovery component. You're going to use that knowledge when evaluating the component itself. The component inspection is going to have two parts, one with the unit off and one with the unit on. I should also mention, as we are going through these steps, if you find that at a point in the evaluation that the exchangers need of remediation, you would take the necessary step at that point. However, for purposes of keeping this discussion short, I'm going to discuss them all together after this section. So with the unit off, is the component clean? I can't stress how important this step is. A dirty component will block airflow, and this will have a negative effect on the fan system, which determines airflow and pressure. So some of you may be asking, what's the dirty wheel look like? Here's a couple examples. You'll see visible blockage, bridging of the airflow passages, dust, dirt, grime will be visible on the surface of the heat exchanger. Next, is there any visible damage? This could be loose or missing sections of heat exchange media, or any structural damage to the frame, missing fasteners, rivets. Once again, if you're curious to see what that looks like, here you can see some examples. You see obvious sections of heat exchange media missing, severe corrosion which affects the structural integrity of the wheel, delaminations of media, and so forth. Are the seals in good working order? And if they are they set properly? The two most common seals in the market are non-contact and contact seals. So you're going to want to consult with the component manufacturer to determine whether the seals are still in satisfactory condition. And if they are, you would use the manufacturer's provided instruction to make sure that they are set properly. Air Exchange uses a non-contact seal, so you'd essentially check the depth of the seal to ensure it hasn't been worn down over time, and you would then follow our operation and maintenance instruction, which can be found on our website, to ensure it's set properly. Lastly, is there purge equipped? A purge is recognizable by its triangular shape, and it could either be a fixed purge or an adjustable purge. In Air Exchange's case, we use an adjustable purge, so you would take note of the angle and you would use that in determining the EATR of the component. The following steps of inspection are for when the unit is on. And also, once again, if you found that the component required cleaning or was damaged, remediation steps should have been taken prior to continuing on. So let's assume we found the component to be clean and mechanically sound. The next step is the wheel turning. I always recommend visually confirming this at the unit rather than relying on the building management system. And that's because personally I have come across many cases where the system is inaccurately showing the wheel operating. Is the wheel turning at the correct RPM? The EATR is dependent upon the wheel turning at its factory set speed, and over the course of the operation, things like control changes, third-party motor and pulley replacements may have inadvertently changed that operation. So you'd want to consult with us to determine whether that's the correct speed for your particular model. Is the wheel turning in the correct direction? This is especially critical for systems equipped with a purge. Most wheel manufacturers, Air Exchange included, have rotational arrows on the frame. Once you would want to visibly inspect that the wheel is rotating in the correct direction. The next step looks at operating pressure. Static pressure in an ERV system is absolutely critical in determining both flow and EATR of an energy recovery component. And while fan locations are critical in developing the pressure profile in a system, as we go through these, don't be overly concerned if your system has one configuration over the other. The first configuration is the push-pull configuration, where the supply air fan is on the outdoor air side of the component and the exhaust air fan is on the exhaust air side of the component. These systems are particularly good at minimizing EATR, and also keep in mind that the fan on the OA side may in fact be a booster fan and not the fan responsible for delivering the entire supply airflow to the space. The next configuration is the pull-pull configuration, where the supply fan is moved downstream of the component to the supply air side of the system. Typically in these types of systems, the supply air fan is used for delivering the entire mixed airflow. The next configuration is not as popular as the previous two, but does exist in certain applications, and that's the push-push configuration, where both the supply and exhaust fans are moved upstream of the component. And the last configuration, which we do not recommend at all, is the pull-push configuration, where the supply air fan is on the SA side and the exhaust air fan is on the RA side of the wheel. These systems result in significant leakage, and if you find you have one of these systems, I personally have never come across one, but that doesn't mean they don't exist. But if you do, please consult with the unit manufacturer. So now that we have a basic understanding of the common fan layouts, regardless of which one you have, what you are going to do is take a static pressure reading in each of the 4 compartments that surround the component. So the next step is, what is the static pressure in each compartment? The compartments do coincide with the testing station locations that are used in the HRI certification process. And what you're attempting to do is to determine the driving pressures behind flow and leakage. Without going into too much technical detail, you would want to ensure that the driving pressures are correct for properly minimizing leakage, and also that pressure drop across the device is consistent with the required airflow. So without going into too much technical detail, you'd want to ensure that the driving pressures are correct for properly minimizing leakage, and also that the pressure drop is consistent with the required airflow. I'm displaying some arbitrary symbols here, but in essence what you want is the driving pressure scheme developed in a manner where the air naturally wants to move from the outdoor air side to the exhaust air side. Now, keep in mind that if the system was designed properly, these leakages would have been taken into account during the fan sizing portion. So in this particular case, we have a positive pressure against a negative pressure, which is pretty easy to calculate the differential. But in systems where both sides are subject to a negative pressure, you would use the same method. It's just those systems usually don't have as high of a pressure differential and are more neutral in nature. So to summarize the previous items and to make it easier on everyone, what you should record is the date and unit information. This should include the cabinet model number, the component model and serial number, and the unit tag of the system that you're taking readings on. Is a purge equipped, and if it is, what is the set angle? What is the wheel RPM? I suggest tacking the wheel itself and not the shaft of the motor, as there may have been some belt slippage occurring, especially if the unit's been in service for a little while. Which compartments are the fans located in? The static pressures in each of the component locations, and try to take them as close to the component as you can. And lastly, if you have the ability to, record the outside air and exhaust airflow. These values can be used in conjunction with the component pressures to determine if there are any airflow related items that may have arisen over the course of the unit's operation. So if you followed all these steps up until this point, you really have done your due diligence in following the best practices for getting the unit ready for occupancy. So aside from what we've already discussed, what are some other considerations you can consider prior to establishing occupancy? Should you increase the outside airflow? We've already discussed this briefly, but during a pandemic situation, it is advisable to increase the outside air. That is, as long as you can maintain control over the space conditions. Once again, it's critical to understand how changes to the system are going to affect occupant health and comfort. Should you add a purge? If the system has been designed without a purge and was designed with proper understanding of the fan system and leakage rates, you should already have an acceptable value to begin with, and when considering the total recirculated air, that should be quite low. However, if going through these steps you find that there is a necessity to add a purge to the system, it can be done in certain situations. Once again, it's critical to understand how adding a purge is going to affect the airflow of the system, and most likely you should consult with the unit manufacturer prior. Should you increase filter efficiency or add filters? During this time, it is possible to increase filter efficiency or add additional filters to sections of the cabinet that may have not had any prior. Generally speaking, adding filters or increasing the efficiency of the filters is going to increase the overall pressure drop of the system. So you want to take that into consideration when determining whether you have adequate system fan capacity to do so. Does your system use demand control ventilation? It's really important to understand how operating DCV is going to affect airflow delivery as well as leakage. Unlike a constant volume system, as velocity changes across the heat exchanger due to a call on different outside airflow rates, it is going to change the leakage rate of the component. So understanding how this is operating is going to be an integral part of your startup process. Most modern systems incorporate some form of economizer mode. The economizer mode should be tied into the ERV operation, and if there's a bypass is integrated, bypassing the component during that economizer mode or period. Lastly, re-entrainment may be a portion of the total recirculated airflow, so it's really important to study the location of the exhaust and outside air intakes to make sure that they have been designed properly and follow proper system design to minimize any re-entrainment from happening. So you're either going to have a unit that is HRI certified or not. All air exchange components are HRI certified, and what's particularly helpful in this situation is that pressure drop and leakage is a certified value, and therefore an item we can accurately determine based on the items recorded on site. And generally speaking, if you have any concern, always consult with the manufacturer.